No, Isaac covered all of this. Like I said, I taught North Brunswick Middle School. I taught robotics, aerospace engineering, computer science, a whole bunch of stuff. I had some great summer classes, theories of time travel, quantum mechanics. Then I taught at Princeton for the summer scholars program or the gifted and talented program. So this is different. So I always do life in the universe, exploring Mars, or a bunch of things. So when you have questions, raise your hand. It's kind of normal. So today we're going to discuss, and again, none of this exists. Warp drive, hyperdrive doesn't exist. So can it? We think it can. So we're going to discuss possibilities. So if I go too fast or you need me to repeat something, please ask. Of course, this is challenges of space travel, distances. It takes us 3 days just to get to the moon with our current technology. Mars would be, I think it's 6 to 8 months there. We'd have to stay there 6 to 8 months, and then the trip back would be 6 to 8 months. And that's depending on where Mars is compared to Earth. There's something called the launch window. We want to launch not when Mars is closest, but at a certain way, timetable where as Mars orbits, we'll beat up with it the quickest. So it's not when they're exactly close. It's actually when it's about to get close. It's weird. It's called the launch window. So, I mean, that's just, so you're looking at an 18-month trip just to get to Mars right now. And what are the challenges besides distances? Radiation. Mostly solar wind, but as we get farther out, there's something called cosmic radiation, where the sun is solar wind called the heliopause, where the solar winds extend ends, and cosmic radiation, like the solar wind from outside. So there's so many things that we have to deal with. Energy sources, we need something sustainable. Rocket fuel, once we use it, it's gone. So we're looking for some type of sustainable energy, solar power, ion power, something. The one good thing, once we start moving in space, we keep moving. Nothing slows us down till we want it to slow down. So if we throw a baseball in space, 50 miles an hour, it's going to keep going until it's acted upon. So trust that made sense. But so we got, like I said, I'll get into more. I'm sorry. Distance problem. Again, things are far away. Proxima Centauri, which I'll talk about, is our closest star system to us. It's 4.3 light years away. So if we're traveling at the speed of light, it would take us 4.3 years to get there, and then 4.3 years to travel back, to get back, if we could travel the speed of light. Here's the problem. If we send you at the speed of light, Alpha Centauri, it'll take you 4.3, and then you'll come back. You'll have aged maybe 9 years. We'll have aged over 50. Because the faster you travel, time slows down for you. That's Einstein's relativity theory. So the distance problem is really, we don't know how to get there within a short amount of time. Wormholes are a possibility. Wormhole is like digging through an apple, goes from one end to the other. So what wormholes does is what warp does, it actually bends space. Here's Paris. Here's us in East Brunswick. Here's Paris. This is space. If we could fold space or create a path, that's a shortcut. That's what a wormhole is. And like I said, with space-time, if we warp space, we just bend space. I have a big mat I used to show my students, a big plastic mat. And they would stretch it, and we put something in the middle of mass and then roll a marble around it to show how gravity works. But that's what gravity does. Gravity bends space. Propulsion technologies. I mean, we have some ideas. We have antimatter energy fusion we could do. It's just a matter of containing it. Antimatter, that's what Star Trek used. Antimatter and matter are the best known energy source because when they collide, it's 100% energy conversion. A hydrogen bomb, which is fusion, is 25% matter to energy. Antimatter is 100%. Problem is getting antimatter, containing it, because as soon as we create antimatter, it annihilates with matter. So how could we contain it? They do it in magnetic fields. They actually made, I just saw they made a couple, not only anti-hydrogen, I think they made anti-lithium, anti-helium, and anti-lithium. So we're able now to create some higher elements with antimatter. Does everyone know what antimatter is? It's the exact, an electron is a particle that orbits a nucleus, has a negative charge. In antimatter, the electron is positive, called a positron. When they hit 100% annihilation. So that's what antimatter is. So it's going too fast. Cosmic radiation and health risk. The people on the space station, their heart rate slows down, their muscles get weak, their bone density gets weaker. We did a whole unit on this in school. There's nothing we can do. They strap themselves to a treadmill and they run on the treadmill, the astronauts. But not resisting gravity, their heart rate slows, and like I said, their muscles weaken and their bone density gets thinner. When they come down after being a year, it takes them, I believe, a week or two before they could just walk on Earth because they're so used to floating, and everyone thinks that's great, but it's really not, and their digestion gets affected. Everything about space is not meant for humans to be there. So, yeah.
So the gravity problem. Yeah, you all look at a science fiction movie or something, and then you see that stereotypical rotating ring space station that produces a sort of a centripetal force, exactly, pseudo-gravity. Would that be a viable alternative?
Absolutely.
Oh, so that would
be one of the best. What this gentleman just mentioned, something that spins creates a centrifugal force, and it's an artificial gravity. And that would help if we resist, even if it's close to that of Earth, that would help. Question. So, I guess you already did my correction for me. So I have we just want to. Always up to that episode. I just think the one starts this thing to 2001. So yeah, so that's it. No, actually, no, he's right. He's saying we should for space cup exactly start with our own move. Where would you go next? Venus and Mars. What's the problem with Venus? Now we need to set up floating cities. Correct, and then we're headed towards the sun. So I would say Mars. If I had to predict, I would go Mars next because we could set up a case on the planks. We have to, have a shielding and stuff. So cities on Venus would have to be floating, and cities on Mars would have to be shielded. Yes. So neither are right alternatives. Shielding on Mars, how could we do that? What do we have on Mars that we could do to shield ourselves? It's the radiation shielding. Yes. The Mars dirt. If we put layers of the Mars dirt on the top floor, there's heat in Mars. We think we might be able to lava tubes. We think we might be able to do it. A float on Venus would be orbit just like steady stage. We can already make stuff like the ISS. Yes, exactly. And I think you're right. I think he's 100% right. Orbit Venus could work, but we can't land on Venus because of the temple. Mars, they can land on. I would say the moon would be a great stepping stone. And then we go to Venus, and then we go to Mars, and then possibly Jupiter's moons. And again, there's a great movie. It's called L5 City in Space. I'll get to you one sec. And what they did, it's a floating city, and they have generations on it, and it goes to Jupiter and the outer planet. It takes years for them to make that distance. But it's a really good movie. You could get it on YouTube. I deal with my students called L5 City in Space. You had a question?
First, if they're going to, I think eventually use Gateway as like a place to site things to Mars, some ordering.
I think it was Elon Musk. There was a plan. He's going to send the settlements first and then the people. And I think they had 50,000 volunteers. My daughter said I couldn't be volunteers. But they had 50,000 volunteers. Here's the problem. You may not come back. Right now, those volunteers, they know it could be a one-way trip. So do you have another question? Oh, sure. Okay.
Look, so I'll kind of up by saying you have to spend 6 to 8 months on Mars. Why?
The launch windows, the alignment between the orbits, and I may not explain, the alignment for us to go there.
And it's still going out here.
Yeah, coming back, yeah. Got to have those. And now, if we get better propulsion systems, it could change. Yes.
Nuclear fission plants is a cookie. Way better propulsion systems.
They could. Fusion, like I said, fission has a lot of radioactive waste. Where fusion wouldn't, but containing, just like on Earth, we thought when I was a high school student, way back in the 80s, I used to work at the plasma physics lab 1 day a week. And I'm like, wow, this was 1985, dating myself. And I thought by now we'd have it perfected. As you know, fusion is very hot, but they contain it with magnetic fields. But every time we do it, we're putting in more energy than we're getting. We're smashing hydrogen together. They use tritium, which is an isotope of hydrogen. They smash it together. And I went there. I said, guys, it's been 30 years I hear. What's the problem? Gravity at the cosmic level, gravity is a great thing when it's something the size of the sun to spark this and contain it. Only once so far have we got it where it's really given us more energy than we put into it. But once we start it, we're hoping that it can go. But I thought it would be perfected by now. It still hasn't been. But if we did have it in a ship and we used it as an exhaust, it could get us maybe half the speed of light.
What's that thing?
Sure. Given all the issues at time that inevitably fusion's going to be the win out, I mean, there doesn't seem to be any other really viable long.
There's exotic types of matter that they think may exist or may not. Mm-hmm. There was one movie, what was it called? Either Supernova and another one where they used something called ninth dimensional matter. We think the universe exists in 10 dimensions. 4 we witness. We have the 3 spatial dimensions and the 4th one being time, but they think that there's 6 dimensions rolled up. And that if we can maybe unlock these, that they think in so-called M theory or superstrings, they think that there's smaller dimensions. They had this 9th dimensional matter which kind of powered
Supernova.
It was supernova.
10,000.
Yeah.
Sorry, librarian.
No, please help me. No, please. I thought that was it. And now this new matter or these if we could ever develop every particle has an antiparticle. I was talking about matter. So there's a force of gravity has something called a graviton. Can we generate anti-gravity? There's been people that said they saw alien ships, and the one thing I give them, they said it was powered by anti-gravitons that were generated. Now, how fast that would propel you, I don't know, but if I could generate anti-gravitons, I could float right there. We haven't been able to do that, so I'm hoping with either some type of, I don't know, if antimatter or something that we'll be able to generate what I'm going to talk about in a minute. Yes.
For interstellar travel, do you think it's use Starship or do you need like a bigger ship?
Don't know. Now, to generate the energies, unless we find something to generate the energies to get even to Alpha Centauri would take a long time, and the ship would have to be big, so we'd have to assemble it in orbit. So, I want at least see where I was. This is great discussion. I can just sit here and talk all day. Radiation shielding I talked about, and again, advanced medical technologies. Something that's brought up, gene therapy. Altering humans at the DNA genetic level to be more adaptable to space. It's a possibility. I'm not sure I agree with it, but it is a possibility. So,
It could be plausible soon.
oh, it's very plausible. I agree. Proxima Centauri, we can't see it in our night sky. I think we have to go to the southern hemisphere. It's a red dwarf. It's actually part of a triplet. There's 2 stars that are like our sun, Alpha Centauri A and B. And this one that orbits the outside, it's the closest star to our sun right now. But the whole Alpha Centauri. What?
Is that bright one at AAAP? That's
No, I don't know why that's there.
was it either turned away, isn't it?
No, I don't think that's part of it. I know this is a weird picture. I gotta get a better one. You're right. But it's just a tiny red dwarf star. It happens to be the way it works that it's the closest. Yes.
So, yeah, space is like super duper. Closest star isn't even within 1 parsec of us.
Yeah. A parsec is 3.3 light years. You're right. So this is a little more than a parsec. Oh, wow. So this is our cloak. Now, one thing I read they're also doing, they're looking at this a ship maybe as big as, maybe this big. And it's just going to transmit back, but they're going to try and accelerate it and use laser and a solar sail to get it as 70. They think they get 70% the speed of light. I think it was 25 years that'll get there. Now, though, when it sends signals back, those signals won't get to us for 4.5 years. So just like if I texted anyone on Proxima Centauri, they'd get a text in 4.5 years, like my daughter. That's what's up, Rob. Round trip. Yes.
It's a red dwarf. Has anything like Hubble or Webb taken a look at that to see if there are any planets in that star system?
I think they did find one recently that was part of one. I think it was orbiting one of the Alpha Centauri B. I think they did find some possible planet, but now there's no triplet star system.
There's some planet.
That's a great point. Well, you could just go explore and come back, but yeah, you want an exoplanet.
It's not like we're going to just stop there and go, hey, yeah, all this stuff for license.
You're right. I agree.
Sorry, was a little late. Do you take flyers or anything?
We were here.
I don't.
I didn't think of it. Should us.
I had a few things I gave to the Kings, but I don't have any flyers somewhere.
No, my show was my grandson, so. Here, have something.
I have something for you. My last handout.
I didn't know you was back here.
Oh, that's okay. Yes.
So, pretty. Let's see. Part B is actually the refuge that makes Venus or Mars look like paradise.
I think it's part of, okay. I wasn't, yeah, there's an order. Alpha Centauri B, not Alpha Centauri. Alpha is a
Proxima Centauri.
Alpha Centauri B. Proxima Centauri is the red dwarf. Proxima Centauri B is like our sun, but what he's saying is it's really close to its planet. The first exoplanet we found was bigger than Jupiter and orbited star in 4 days. Its surface is 4,000 degrees. That was the first one. And we found it, by the way, the star wobbled as the planet orbited. The star wobbled a tiny bit. Our sun does. And that little wobble, the red and blue shift, let us know. And they could tell the mass of the planet. Now we use transit. We use direct imaging a little bit. And Isaac, what's the other one we use? Direct imaging, transit, radial.
That's the first. Like,
the direct imaging now with Webb, we're getting some. We're trying to use some of these exoplanets, trying to sample their atmospheres to see what elements are in the atmosphere. If it's oxygen, nitrogen, or maybe even a little bit of carbon. Is it Earth-like? So, but this is the closest one. And like I said, to get here is, even that little ship they want to send will take a long time.
Well, Chuck, how did they ever figure out that little insignificant star is gravitationally locked to the 8th Bayer?
That's fishy.
They just try to watch it for many years?
Again, I don't know. Or maybe they do track stars. There's people, and now with computers and supercomputers and AI, it's very easy to track the location. That's how they found Pluto, back in the 1920s. So, again, warp drive. This is what Star Wars actually does it. But again, warp drive, we're taking the space in front of us, we're shortening it. So if I'm in the middle of this paper towel, I'm shortening the space in front of me and lengthening the space behind me. So this is what it does. It's going this way, it's short, it warps space, it takes space and it bends it. You're a warp factor 10, I think was the highest they could get to. You're getting a massive curvature of space. So like warp factor 1 is the speed of light, close to the speed of light. Warp 2 is actually 8 times the speed of light. I think it goes by a factor of 8. Warp 3 is 64 times the speed of light. So with warp drive, it's a guy named Alcubierre came up with this, and it can work. It doesn't violate the laws of physics. We can't travel faster than light. We cannot go faster than light. We have to find ways around it. Bending space does not violate Einstein's special relativity. You're not going faster than light. Yes.
So, that same process that's already used. So it's like, no,
Probably not. Probably. I don't know if we'll find anything close. I think the closest one they found is 20 light years away. But trying to get, now there's a particle called, theoretical particle called the tachyon. If you ever watched Star Trek, you've seen the tachyon. What a tachyon is, particles can't go faster than light. Tachyons can't slow down. They're on the other side of the light barrier. They're moving so fast they can't slow down to the speed of light. If they exist, there's also a theory, which I didn't include in the presentation, but if you surround your ship with tachyons, a tachyon field, then maybe that tachyon field can go faster than light. Because it's already, those particles, how we would catch them to control them is years away. But particle called tachyon, we think they exist. Yeah, we can't prove it. And again, it's on the other side of the light barrier. How it got there, I don't know. But again, a warp drive is warping space. And again, how do we know space warps? The sun warps space. The moon goes around Earth because Earth warps space. Again, if I took a big mat and I put a bunch of heavy objects, that's what I did. I had my students each hold a mat. It was like almost like polyester or Under Armour. At first they did it with an Under Armour shirt that someone left. Then I got a big mat and I put heavy objects and then took marbles, and the marble followed the path of the warping of space, of the warping of that. Again, it's two-dimensional, but they actually got to see. And for my visual learners, that was good, because me explaining it's one thing. When you actually see a mass warping something, it's interesting. General and special relativity. Special relativity is the speed of light. That speed is not the same. It depends on the observer and where you are relative. If I'm on a train going 50 miles an hour and someone's in a plane going 100 miles an hour, relative to me, they're going 50. And if you're stationary on Earth, it's going 100. But again, the Earth is moving, the sun is moving. There's no frame of reference that is universal. That's the word I was looking for. Universal. But again, the faster you move, time runs slower. And we don't see it except our GPS. How many of you have GPS? Everyone use it? 4 seconds delay. Because the satellite orbits so fast, it has to be 4 seconds back. Otherwise, it'll be too fast. Because that is moving so fast, time runs slower for that satellite. But when we get real speeds, like 75% the speed of light, we see that effect. How do we know? Well, we see particles and accelerators that should decay in a certain amount of time. The faster they move, the longer they live. So we know time runs slower. So that's special relativity. And again, there's so much contraction, expansion, and then they say you can't break the speed of light because E equals mc squared. It would take an infinite amount of energy. Your mass would increase, and it would take an infinite amount of energy. So we can't break that barrier. Again, we could cheat, but we can't break it. General relativity is how gravity works. Wait, again, black holes, curvature, space-time. The best way to demonstrate it is that mat, or if you take a piece of plastic wrap or something, if you ever need to physically show somebody how curvature of space-time works.
just get that trampoline.
Yeah, trampoline's perfect. Trampoline, I wish I had one at my my former job. Einstein's theory said that space and time are related, that, faster you move, again, slower clock runs, things like that. Miguel Alcubierre is the one that came up with the warp drive, that space could be bent, and we see it at black holes. If you orbit a black hole, Interstellar, Matt McConaughey went to a planet orbiting a black hole. And 1 hour was 6 years or something. How was 7? Yeah, 7 years. And my students were they're like, what? His daughter aged because he was trapped on that planet for a little while. He was freaking out because he knew how that his daughter would grow up without him. So warp coils don't exist, but again, they have to generate a field that allow us to warp space. Here's the problem. A small ship, even the size of the Enterprise, how is it going to warp space without something? I mean, a warp coil seems to work, but you got to generate you got to control a lot of energy. They judge civilizations. They say a type 1 civilization, which is almost us, we're like 0.7, where you control the energy of a planet. A type 2 civilization controls the energy of a star. Anyone hear of a Dyson sphere where you build things around the star to take the energy? And a type 3 controls the energy output of a galaxy. So you would have to control those type of energies to really, as our understanding right now, to really curve and warp space. So I'm hoping one day we break this, but when talk about life in the universe as a Fermi paradox, well, if there's aliens, why aren't they here? This could be why. Yes.
Why I thought this is Fermi paradox that aliens are simply way too far away to detect.
Could be. Or like the Prime Directive in Star Wars, they don't consider us, they just study us. They're just, they're just observing and not interference.
The Prime Direct also another thing. So it's Prime Directive. Yes, we're just not advanced enough to detect aliens in the first place.
Could be. Oh, I disagree. I think SETI, which has those radio telescopes, we thought we had one signal, called the WOW signal. We just haven't been able to find it again or duplicate it, but we send out radio waves. Okay? Aliens within 100 light years of us know we're here because they have technology. They can watch I Love Lucy. They can watch all the old shows, Three Stooges. Now they're getting, within 10 light years, they can watch Friends and all these shows. We can't help it. Those signals go into space. So they can detect it. That's what we're searching for. If we find that signal, we'll know that, that there's an alien civilization. That's the best way. Yes.
How do we know that? That they are receiving the signal?
Well, they're out there. We know they're out there in space. We know, I think it was Voyager, the first Voyager was able to detect out. So we know they're traveling. We know they're going out there. So we're thinking, well, maybe we could find something like that. In the movie Contact, Jodie Foster, they found the signal and transmitted it back to us. The first TV signal was the Berlin Olympics, and that's what they sent back. But that's the best way for aliens to find us or for us to find them, is that our radio. We're listening for radio waves. And it's very hard to find. And then if we find it in a certain area, we have to, again, justify it, things like that. But you could do that kind of research in your backyard, set up dishes. I know people have done that. It's kind of interesting. Sure, please.
How are you achieving time travel to the future with work?
I don't know if you aren't.
This was one of the bullet points. Time travel to the past, no time travel to the future yet.
Time travel, here's the problem with time. I taught a class on this. Time travel to the past may not work because something called the second law of thermodynamics, that entropy always increases. So they think that that's why time only flows in one direction. I mean, technically, if we could travel faster than light, it would send us back in time. Somewhere maybe I messed up here. How would it be in the future? I guess if I got ahead of it, so fast I could get into the future and then travel back. I think I don't have an exact answer. I don't know why I put that in there. I apologize because I'm trying to think like how it. And originally this was supposed to include theories of time travel, and then I took that off.
Well, I mean, logistically, you kind of described it already, right? You know, as you get closer to the speed of light, time moves slower for you. You take a long trip, you age 4 years, you come back, everyone else is age 50. Would you not consider that time travel into the future? Because only like 4 years has elapsed.
Not really, but it's just time ran slower for me. Time ran slower for me, so it's not really traveling into the future. I know what you're saying. It sounds like it would be, but it's really just that time ran slower for me. Like if you could see me on that rocket ship, you would see my clock running slower. It's weird how they and all these thoughts, very like Schrodinger's cat, all these take things. This originally was going to be theories of time travel and shorten it. I cut it short. Again, the Alcubierre drive, faster than light, warp in space. I apologize. I kind of want to. This is the first time doing this one, and I realized that I'm talking about the same things. Negative energy they talk about. I don't know if that exists. I don't think it does. But again, it's like the anti-graviton. There is a possibility. There's something called negative mass, a Alcubierre effect, that if you get two plates close together, it actually generates negative mass or generates negative mass particles. Black holes eventually evaporate. Stephen Hawking found that particles pop into existence. Quantum's weird. Quantum mechanics is weird. Particles pop into existence and pop out. What happens near a black hole, if a negative mass particle generates, so does a positive mass. And then they pop out. But near a black hole, if the negative mass falls in, that makes the positive mass real. And the black hole eventually evaporates because of this quantum effect that it's called Hawking radiation. I think it was in the new can't think of the show. Lost in Space. There was a new Lost in Space series, and she detected Hawking radiation, and that's the effect of quantum mechanics. Is weird. If anyone could explain it, let me know. And I taught it. There's so many effects. Particles that are light years away. If one particle spins one way, the particle does the same thing. It's called quantum entanglement. How does that work? How is it faster than the speed of light? And I just saw an article that they think maybe there's a wormhole connecting these two particles, but we don't know. And Einstein hated it. He called it spooky action at a distance. Why if one particle does this, if it's entangled, does the exact same thing? Well, how can that work for us? Communications. It would take, I think, 4 minutes for me to call someone on Mars. Now with quantum entanglement, once one particle did the one thing, the other particle would do it on Mars. So we're using quantum entanglement to maybe one day allow for what's called subspace radio. How that would work at our level, again, what happens at the quantum world doesn't translate to our world all the time. But if we could generate these negative mass particles, create this negative energy, create anti-gravitons, that could do a whole bunch of things.
Do you know anything about your background? This guy, was he like a scientist or a writer?
Yeah, I think he was a scientist that became a writer, just theories. Have you guys seen Michio Kaku? He has it where he had a show, Impossible Things in the Impossible, and he tried designing a lightsaber and other things and how he would do it. And that's what Miguel Alcubierre was. So I got to redo this. Now that I'm teaching it, it's easy to put something in a PowerPoint, but I'm actually explaining it to people. It doesn't flow. So I apologize. It's not where exactly I want it to be. Again, the Enterprise used warp drive. So again, real world physics. We're not breaking the laws of physics, which cannot be broken, as far as we know. But what are ways around? And these two things were the warp coils. They generated that field, and it still never exactly, even though it generates the field, I don't understand the propulsion of it. Yes.
So, I want to talk about Star Trek, how the Enterprise.
Sure.
So, vaporizing someone that isn't so about what people really do believe. You apply that to a real person, you just make them explode.
I don't know if they do it with lasers, but if you could fire a beam of anti-matter
like liquid, but it's like if you added up energy, vaporizing, you're adding energy to turn a liquid or solid into gas.
Or not even in gas, it's energy. You're taking my matter and changing it to energy.
Disintegration.
You're saying evaporation?
No, disintegration.
No, but disintegration, yeah, I guess would be changed to me as energy. What, with the Star Trek, you said that was evaporation?
Evaporation, it's turning. By evaporating, you would be
Turning solid to a gas.
You would be gone.
Either way would be fun. So, now, I want to get to Star Wars before. Let's go here. You might need to.
It's just like on the body of the slide.
Sorry. Hyperdrive. Here's what Star Wars does. They enter something called hyperspace again. Those 10 dimensions I talked about early on. Star Wars travels through what's called hyperspace. They do not break the speed of light, although he says, like Han Solo does say light speed. They do not break the speed of light. He travels through this subway system called hyperspace. Again, it's like taking an apple and a wormhole. They're really basically traveling through wormholes. But how that works, we don't know. We don't know if it's possible. Because those 6 dimensions are so tiny, how would we open a hole and then travel through hyperspace? And they had to find hyperspace routes and stuff for those Star Wars fans. But is it possible? Yes, it is. Hyperspace is possible. In fact, Michio Kaku, I spoke about, wrote a book called Hyperspace. So it'd be ways, and one good movie was Stargate. But again, the energy would take to open those, but you go in one gate and you come out somewhere else, anywhere in the universe or anywhere in the solar system. So it's kind of a wormhole, but in this, it's like kind of a super rail system, or super highway system, I should say. And does it work? We don't know. And it gives you that effect, but basically you're traveling now. The only problem I have is if they're traveling through hyperspace, are there particles and other things? Like if we hit a little piece of asteroid in our spaceship, it could kill, because that energy possessed by that little piece of asteroid could definitely blow up our ship. So again, I guess maybe some type of field around us to eliminate that. But we're going through something that doesn't exist. We're traveling, well, that we don't know that it exists. So it's really, this is all hypothetical. But could it work? I believe it could. Again, how would we get to those extra dimensions? I don't know. Are particles traveling out to other dimensions? Is quantum entanglement working through these other dimensions? So there are things like that that make us think maybe it is possible. Again, you want to get into, you just get a book or even quantum reality for dummies, and you see some strange things going on. Again, quantum tunneling, where it could go through. It says if I run into that wall 1 billion times, one time I'm going to pass through it. It's really crazy effects. And Star Wars Hyperdrive, Millennium Falcon, they all used it. The only thing I know, the Millennium Falcon a couple times said it traveled near light speed. If it did, he would come back and we would have aged a month at least on some of the trips that they make. So again, hyperspace wouldn't affect time. Sustainable energy, we talked about nuclear fusion, antimatter. We need something. We need some way to generate the amount of energy required to do this. How, we don't know. Again, exotic particles, exotic matter, something like that. Yeah. So I apologize for the flow of this. I mean, we had some good subject, but the flow, I didn't like this. Is great. I didn't like the flow as much.
No worries. Discussion has been great.
Future of interstellar travel, again, as the gentleman pointed out to me before, start with the moon. Everyone wants to go to Mars. That's great. But we should go to the moon first. There's something called helium-3, isotope of helium, which could create fusion engine. Let's start with the moon. Let's use that as a jumping off point to Mars. I mean, Elon Musk and these people, like, private industry is good because everything works on competitiveness and things like that. So if Elon Musk wants to do it, Richard Branson or somebody else wants to do it. So they'll all compete to get us there, and that drives innovation. So future space travel for me is let's get to the moon, then Mars, then probably like Europa. We're sending something to Europa, which is a moon of Jupiter about the size of our moon, but it's a sheet of ice. Underneath that ice is more water than all of the oceans on Earth. Very high possibility for life. Very high. I tried to simulate that in the classroom. It didn't work because you have to keep that ice cold. Because my students, we did explore Mars. I had a big 8x8 pit. I had paver sand. I had everything. And what's great is all their little robotic rovers got stuck. So they had more problems just roving my pit than anything else. And that's how Mars really is. The spirit, opportunity, a bunch of them got stuck a bunch of times. So they had to design it where it could overcome so many things. But Europa is neat because we have to drill through a lot of ice just to get to the surface. So the Europa Clipper's getting there will tell us a lot more about it. But there's an ocean under there. How's it heated? By the way Europa orbits Jupiter. It's squeezed and compressed. And internally, it's got volcanism. Io, which is another moon, has 100 volcanoes going off right now because it's so internally heated by the tidal heat, which is the way it orbits Jupiter. So Europa could be interesting. We want to send some type of sub or James Cameron, the Terminator,
Yeah, right? He's been down there, Challenger.
Avatar, all of that. But his brother's an engineer. What he was going to do is leave, as he drilled in the ice, leave signals to communicate with the sub. Drill down a couple miles, and then the sub would go, but the signals would be able to transmit back to us. So this is my last slide, but that's, again, Moon, Mars, Europa, or one of the moons of Jupiter. Then Saturn, and we'll just eventually move out. And again, that L5 city, if you guys want to watch something, that L5 city in space, it's made for kids, really good. It's about a little girl who grows up on this space station. It's like a big round thing, and they needed water, so the dad had to go to a comet to get more water. But just the story they have, they don't have cabinet, chickens, they have other things. It's a sustainable society with a couple thousand people on it. And it's called L5 City in Space. I think that's could be the future, when we have to send a whole city. Questions, comments? Yes.
So you covered basically all of the really popular styles of faster than light travel from the movies. The one that I didn't hear was, if you've ever seen Event Horizon, pick up and throw away the horror aspects of that movie.
That was a good movie.
Yeah, but how practical would a gravity type drive?
He used a tiny black hole. Yeah, that's a great point. See, that's what I love. You got to make this presentation. No, it's a great point.
You got to drop the horror part.
Move you away.
If there are, we're looking for, if there are extra dimensions, particles accelerator like CERN, we're looking for mini black holes. They'll disappear really quick. But if we could cause matter to form a black hole to, I don't know at what level, and control it, that's what they use to power it. But I don't think they went faster than light.
No, they punched a hole in space and just kind of slowly moved
with the black hole. So they created a wormhole. It's a really good movie. It's like you said, it's more of a horror movie.
Yeah,
they all look wacky. But it created they used a mini black hole to create a gate. Now they think black holes are gateways to other universes. Our universe may have formed from a black hole in another universe. We don't know. We know if we go near a black hole, we'll stretch apart, be spaghettified. So if I go feet first, my feet will weigh more, break off, split up, I'll be stretched, I'll be ruin my day.
It'd be good.
But maybe there's a way to get into a black hole real quick. But then if I do get in, I can't text Isaac and say, hey, I'm okay, because light can't escape. Other question?
Yeah. How are many black holes made?
We don't know they exist yet. We think because of extra dimensional space, we're looking at these particle accelerators. If M theory or superstring theory is correct, we say these particle accelerators, once we get the energies enough, will create these things black holes. And they'll disappear really quickly. They were afraid they're going to create one that's going to engulf the whole. That's not, they would evaporate really fast.
So it doesn't come from a large black hole. These ones, we don't know how they form.
We know they're part of dimensional space time. It would be, but it's at the microscopic level, or the level. Well, we're not sure. What superstrings say is that matter's made up of strings, and you only see fully particles because you're looking at the end of the string. The way the string vibrates in extra dimensional space-time determines the electron, proton, or all the other. So we have tons of particles. We have a muon is an electron that weighs 30 times more. A tau weighs 100 times more. So where are all these particles come from? Why? Superstring is an elegant theory that these strings vibrate in extra dimensional space-time, but we only see that white part.
Makes
Love it.
I was going to say, some of the things that you talked about, at least with the fourth drive, Lawrence Krauss, professor of physics.
Very good.
Yeah, wrote a book called Physics of Star Trek. The only thing,
That is good.
yeah, I read it. I actually was an undergrad at Chase Western Wood USEC. So one of the things he did say was the only thing in Star Trek technology was transporters seemed to be the only impossibility that he saw. Because being able to scan someone, figure out where because of the uncertainty control, you'd have to be able to figure out where all the particles are, take them apart, send them to a spot, and put them all back.
You really create what they do there is they turn you into energy.
Yeah.
And then reassemble you at the other end.
Yeah.
So they're really destroying you. They're destroying your whole body.
Rollins didn't like it.
And but they're recreating it piece by piece. Now, the quantum entanglement, quantum tunneling factors could it be? Maybe. It's not out of the realm, but what would make you reappear? Like, they send you from a ship down there to right here. You would need a pad or something to just beam someone from down here. I don't know how that, but who knows? Maybe they have a projector that does that.
And then the really fun question is the you that walks out the other side actually you or just a copy?
I found that there's also physics of Star Wars, and they said Titan was the largest moon in the solar system, Saturn's moon. They're wrong. We're just email. No, Ganymede. No, it's weird. Ganymede is the largest moon around Jupiter. That's the largest moon. It's bigger than Mercury or Pluto. But it doesn't orbit the sun. It orbits Jupiter. So it's
The question. We keep saying that you can't exceed the speed of light, but that's technically not true. Right. I mean, at the moment of the Big Bang, the speed of light, space-time was faster than the speed of light. So is it not theoretically possible to create a separate, what I've read, and I don't understand it completely, but it's to create a separate set of space-time, and that is expanding faster, and you're sort of riding its horizon.
possibly what happened though, speed of light may have been faster. They said the speed of light slowed down to what it is. Yeah, very fast. But back then, the speed of light may have been faster. And as the universe expanded, the speed of light slowed down. Theory. We don't have proof. Alan Guth is the one that did the, what's it called right after the expansion? Right, now
No, there's a special term for it.
there he is. I can't. But he talked once at Princeton too. He was really good. Inflation.
It's like, right.
So when he's saying when the Big Bang came about, it was a singularity. That when it came out that space expanded faster than the speed of light, they still think it might be, but the speed of light they think was originally faster. It slowed down. This space time.
Like right now, expanding faster than light. I'm always trying to figure out why we can only see 13 billion miles, but the known radius is 48 or something
I
like
don't know
that.
about that.
Like it's like lights falling behind the size of the universe.
Well, it's red shifted. That means the universe expanding. I don't think that the universe is bigger than 14 billion years. Like, I do think it's around that time. Now, is it boundless?
They say the radius of the known universe is more like 40 billion light years.
Maybe because it's expanding out where you have it in direction.
Yeah, does that mean it's actually expanding today faster than light? Because it seems like in time, the portion that light traveled is at 13 billion years. It's becoming a smaller fraction of the known universe.
They measure these.
The answer on that, just seen something on that exact question. And so the whole theory is that light can only travel from a certain time back in distance because of the extension of space. What ends up happening is the waves actually stretch out so far that then they no longer become light and they become what's now known as the cosmic microwave background.
The microwave background,
and
which
it's no
is
longer visual waves because of the stretch
Shifted.
of space-time from light into microwaves.
it's all in the same space. You're not Sammy's mom, right? Sammy King? Okay.
And
And again, we could talk. I love this stuff. We could talk about it all day. I do see some things I'll work on for this presentation going forward. I tried to cover the concepts, but some of them were repetitive. So, but it's my first time with this one. I do life in the universe, Mars exploration, our solar system, black holes, galaxies, and stars, black holes, and galaxies. So I appreciate all your time. I mean, if you have any more questions, or like chat, yeah,
You said this, we're moving the sun following, sir.
yeah, a spiral arm. We're in the Orion arm, trying around the center of the Milky Way galaxy, which we think is a supermassive black hole we call Sagittarius A. We're in a spiral arm. We're like going, and I forget how fast.
It's 200 revolving around something.
It's the black holes. We think there's a black hole. Well, we know there's a black hole. We can't see it, but we calculate how fast stars move around it. And we figure that the mass of that, and there's not
All the other stars are all revolving around a black hole.
right, a massive, supermassive black hole. There's stellar black holes which could be part of solar system, but they're supermassive, like about all of the sun all the way around. Galaxies, how they're 100 light years across. I'm not sure. But it's weird. As we go around, we bob up and down. When we went through recently, we go through like the center. So it like rotates and it bobs up. When we bob through, the last couple times we bobbed through, they traced asteroid impacts. The one that killed the dinosaurs and is one 35 billion years ago. It was an extinction line. But so when we bobbed through, they were afraid that because we're bobbing through, that gravity would send comets and stuff coming our way, some or cloud or control. But it happened. Thank God.
I think I just read that where they said that we might be in the process of colliding with Andromeda at this point.
We will. The two galaxies will. It's billion. It's a couple billion years. They say like 2, 3. Something. And I just saw it the other day. Watching something was 4 billion. So they keep changing it. But yeah. But most of the galaxies are there's so much space that most of it will pass through each other and the two black holes will merge. They create a super galaxy. But once they pass through each other, a lot of gas is going to ignite, create a lot of stars. Could we collide with something? Could our sun be thrown out of solar system galaxy? Absolutely. Could happen. But our sun, I think, has about another 4 billion years. 3 billion years, it'll go nova, expand. My kids panic. Like, I used to tell them that. So,
Just
anything else? Yes.
it's random curiosity.
Sure.
What is your favorite sci-fi show?
Orange. How's it going? I love Star Wars. I love Star Trek. Come here. I have a favorite. I grew up with Star Trek. That was the original. Star Wars came out when I was like 9. So Star Trek I used to watch on TV. It's like Space 1999. Remember that show? But, I mean, you look back at it and you're like, man, the science was so horrible. The moon got thrust out of orbit by a nuclear thing. But it's traveling to other planets and stuff. But it wouldn't reach another planet for,
It's okay.
even if it was going close to the speed of light, it would take 4 years to watch it. Like, man. But the science behind Star Trek, they really did a lot of research. Matter, antimatter, warp drive. They really did a lot of research. Where Star Wars just does hyperspace. But if you look, like, I don't know, for those of you like Star Wars, thousands of years, they only progressed so much. Like, you think of what we did in 1,000 years, who knows where they'd be. So, I don't know. But I don't know. I like a lot. Star Trek, Star Wars are my 2 favorite. So, any other questions? Thank you guys for having me. I enjoyed I'm supposed to come back again soon, so thank you for having me. This is all. You like to fix, say. Have a good day, guys. Thank you. Thanks.